Hi guys, welcome to my channel. In today's class, we are going to be solving systems of linear equation using Cramer's rule. In our last video, we worked on system of linear equation involving two variables. But for today's class, we are going to be working with three variables. So for three variables, it means that our linear equation are going to be having three unknown values. And then if we have three unknown values, it's going to be leading us to a 3 by 3 matrix. So now let's have an illustration of what the three variables linear equation will look like. So we're going to be working with letters to see what the method is going to look like. So to understand the method before we now solve actual question involving numbers and unknowns, you get? So now let's have this illustration. So let's assume we'll have our values to be a1x plus b1y plus c1z all equal to d. Then for equation 2, we'll have a2x plus b2y plus c2z all equal to d2. This should be d1. And then we'll have a3x plus b3y plus c3z equal to d3. So just like what we did in our last video, we are going to express this in matrix form. That's the next thing we have to do, is to express this in matrix form. So for me to express this in matrix form, I'm going to be bringing out the coefficient of x and y. So the coefficient of x, y, that's all the coefficient of x, all the coefficient of y, all the coefficient of z. I'm going to bring it out. And what are the coefficients? They are a1, a2, a3, b1, b2, b3, and so on and so forth. So let's write that. So for our matrix now, we're going to be having a1, a2, a3, then b1, b2, b3, and then the last one is c1, c2, c3. Then after that, we'll close this 3 by 3 matrix we've gotten. Then the unknown variables. What are the unknown variables? The unknown variables are x, y, z. So I have to have them x, y, and z. So, and this equation is actually equal to d1, d2, d3. So I'm going to also have it here. So it is equal to d1, d2, and d3. So the next thing we'll have to do is to look for the normal determinants. So we have to look for the determinant of this first. Then after getting this determinant, we now have to look for the determinant of the coefficient of x, the determinant of the coefficient of y, and the determinant of the coefficient of z. So from our last video, working on the Cramer's rule involving two variables, which is a 2 by 2 matrix, the method we used there is similar to what we're going to be doing here. Just that in the last video, we worked on two variables, but here, three variables. So there we look for the determinant of the coefficient of x and y. So but here we're going to be looking for x, y, and z. So now let's have the first determinant. So like I said, we'll have to look for this determinant first. We have to look for this first. So bringing this out, I'll call it our d is equal to, now let's have the values there. It is a1, b1, c1, a2, b2, c2, a3, b3, c3. Good. So now, this is a 3 by 3 matrix. The first thing we'll have to do is to give it a sign, plus, minus, plus. From our previous video, we've done the determinant of a 2 by 2 matrix and a 3 by 3 matrix. I'll be dropping the link at the description box, so take a look at it if you really need to understand the basics of the determinant of a matrix. You'll get all you need there. So now let's look for the determinant of this matrix. So now looking for this determinant, we'll be having the first element on the row. We're going to be working with the row, which is a1, b1, c1. So remember the sign attached to them, plus, minus, plus. So for a1, I'm going to bring it out. I'm going to be forming a 2 by 2 matrix for a1. So how do we get the 2 by 2 matrix for a1? We have to remove the rows and column associated with the a1. So the rows, this is the rows associated with a1, and this is the column associated with a1. So what do we have left? We have b2, c2, b3, c3. This is what we have left. So I'm going to be bringing them into this matrix box we have here. So that's going to be B2, C2, B3, C3. So now after we've worked with A1, the next thing we have to work with is minus B1, which is the next element on the row. Like I said, we're going to be working with the values on the row. So we have minus B1. So now bringing out the matrix we are going to be working with. So for minus B1, we have to remove the rows and column associated with minus B1. So this is the row associated with B1 and this is the column associated with B1. So the values we have left is A2, A3, and then C2, C3. A2, A3, C2, C3. So let's have that. We have A2, C2, A3, C3. Now we have the last element on the row plus C1. So let's take notes plus C1. So just like we've done with the others, we have to form a 2 by 2 matrix for it also by removing the rows and columns associated with it. So for the row of C1, these are the associates of C1, and these are the associates of the rows associated with C1, and these are the columns associated with C1. So now we are left with A2, B2, A3, B3. So we'll write that A2, B2, A3, B3. So the next thing is to, now we've actually formed the 2 by 2 matrix inside each of them. So this is plus, minus, plus, minus, plus, minus. So what we're going to do next is that we have to find the determinant of the 2 by 2 matrix associated with the A1, B1, and C2. So that is how we are going to get the determinants for this. So now getting the determinant of the 2 by 2 matrix inside each of them. So our D is equal to A1, then a bracket. So the diagonals B2 times C3, which is B2 C3. Then we'll have our minus here. So minus, we have B3, the second diagonal is B3 C2. So we have minus B1. Then we look for the diagonals of B1s. So we have A2 times C3, and then our minus here, which is minus the second diagonal, which is A3 C2. Then we'll have plus C1. So multiplying the first diagonal, we'll have A2 B3, and then we have our minus sign, which is this, and then the second diagonal is A3 B2. So this is the determinant of, like the normal determinant we are going to get first. So remember that these letters are representing numbers. So if we actually have a number like B2 times C3, anything you get, you write down the value, you subtract it with whatever value you have here, and you multiply it with the value of A1 you are given. So that is how we're going to do the 3 by 3 matrix here. Now, we're now going to go back to this, and then coming back here, we can see that we need to look for the determinant of x, just like I said, the determinant of the coefficient of x, the determinant of the coefficient of y, and the determinant of the coefficient of z. So the method we are going to use here is this. Whenever we are looking for the determinant of the coefficient of x, whenever we are looking for the determinant of the coefficient of x, what are the coefficients of x in this normal equation? The coefficient of x, look at them here. The coefficients of x are what? A1, A2, A3. So coming to this matrix, A1, A2, A3 are going to be replaced by D1, D2, D3. So meaning I'm going to replace A1, A2, A3 by D1, D2, D3 because I'm working with the coefficient of x. So now let me write the matrix that will give us. So our determinant of x is going to be, like I said, we're going to replace the A1s. It's going to be D1, D2, D3. And then we'll have others like that, which is B1, B2, B3, and C1, C2, C3. So this is the determinant of x. Now we're going to find the determinant just like we did with the normal determinant, but there's no point doing it since you already know how to get the determinant using the normal one I did there. So now let's find the determinant of the coefficient of y. So the determinant of the coefficient of y, what we're going to do is this. We're going to come back here. The coefficient of y are what? B1, B2, B3. So meaning I'm going to replace this B1, B2, B3 by B1, D2, D3. So every other value will remain the same. The A1s will stay on its own and the C1s will be on their own. So the only thing that will be changing is the B's, which will change to the values of D's. So our determinant of Y, our determinant of the coefficient of Y is, we'll have our A1, A2, A3. Then the B's value are changing to D1, D2, D3. And then we'll have our C1, C2, C3. So this is it. Then the last one we have to change there is the determinant of the coefficient of Z. The determinant of the coefficient of Z in the equation, the coefficient of Z are C1, C2, C3. So meaning I'm going to replace the C1, C2, C3 with the values of D's, which are the D1, D2, D3. So the A and B remains where they are meant to be, then the C are changing to D's. We'll have our determinant of Z to be, so they are going to be A1, A2, A3, B1, B2, B3, and the C's are changing to D1, D2, D3. Now, after we've changed them, we are going to look for their determinants, just like we did with this one. That's with this whole process. This whole process from here, that's all of this, and then coming here to get this. We are going to look for their determinants also. But I wouldn't want us to spend most of our time here, because when we have a normal question that has to do with numbers, we'll be able to do exactly what we've done for the normal determinants. We're going to use it to get the determinant of the coefficient of x, y, and z. So I want you to understand, as you notice the pattern here, is that the coefficient of x, they change to D1, D2, D3. Coefficient of y, they change to D1, D2, D3. The coefficient of z, they change to D1, D2, D3. So that's the pattern. So now after we've looked for the normal determinant, which we called D, and then we look for the determinant of the coefficient of x, the determinant of the coefficient of y, and the determinant of the coefficient of z. So now to get the unknowns, to get the values of the unknowns, and remember the unknowns are x, y, z. So now for me to get the value of x, it's going to be x equals to the determinant of the coefficient of x all over the normal determinant. Now getting the value of y is going to be the determinant of the coefficient of y all over the normal determinant. Likewise, the same thing for the value of z, it's going to be the determinant of the coefficient of z all over the normal determinant. So this is the method we're going to be applying to solve for the systems of linear equation involving three variables, whereby we are looking for three unknowns. So now let's have an actual examples. So questions. So now we are given the following question. Solve the following equation using CRAMER'S rule and find the values of x, y, and z. So the first equation, this is it, A. So now let's solve for A. A says 5x minus 6y plus 4z equal to 15. 7x plus 4y minus 3z equals to 19. 2x plus y plus 6z equal to 46. And now we are asked to find the values of x, y, and z. So from our illustration we did earlier, the first thing we have to do is to transform this into a matrix form, which is going to be, so remember we are going to be bringing out the coefficient of x, the coefficient of y, and the coefficient of z. So the coefficient of x is 5, then we'll have the second one as 7, the third one as 2, and then the coefficient of the y's are minus 6, 4, and then 1. Remember there's a coefficient, there's an invisible one here. And then for the z, we have 4, minus 3, and then 6. So after we've done this, so the next thing we have to form are the unknown values of this equation, which are x, y, and z. So this equation is equal to, we'll have 15, equation 1, 19 for equation 2, and then 46 for equation 3. So now that we form the matrix of the given system of linear equation, so the next thing we have to do is to look for the normal determinants, meaning that this is a 3 by 3 matrix, remember. So we have to look for the matrix we have to look for the determinant of this 3 by 3 matrix. First, is after we've gotten this, we can now start looking for the determinant of the coefficient of x, coefficient of y, and coefficient of z. So now let's do this one first. So our D is equal to, we have them to be 5, 7, 2, minus 6, 4, 1, 4, minus 3, and then 6. So looking for the determinant of this, remember that we have to have our plus, minus, plus, plus, minus, plus. So now working for the determinants, we're going to be getting something like this. So let's have it. Now this is going to be equal to the first element on the row is plus 5. So we're going to have 5, then the 2 by 2 matrix we are going to be forming for this is going to be, so the element, the rows associated with this 5 are this, and the column associated with this 5 are this. So what do we have left? We have 4, minus 3, 1, and 6. So we're going to write that 4, minus 3, 1, and 6. Now we'll have a minus sign here. So I'm going to have a minus. And then what do we have for the second element on the row? It is minus 6. And then we'll have minus here. So minus times minus 6 give us plus 6. So now we'll have our 2 by 2 matrix to be. So the elements associated with this minus 6, that's the rows and column are. These are the rows associated with minus 6, and these are the columns associated with minus 6. Now we are left with 7, 2, minus 3, and 6. So we're left with 7, 2, minus 3, and 6. Now we'll have the last one there, which is plus 4. The last element on the row is plus 4. So removing the rows and column associated, these are the rows associated, and these are the column associated with the 4, the value of 4. So now the next thing is to bring out what we have left. We have a 2 by 2 matrix left, which are 7, 4, 2, and 1. Now let's form a matrix for this. 7, 4, 2, and 1. So now these are now 2 by 2 matrix. 2 by 2 matrix. So now that we have a 2 by 2 matrix for the following elements, which is 5, 6, and 4, we have to find the determinant of this 2 by 2 matrix. And what's the first thing we have to do? Remember to have your plus, minus, plus, minus, plus, minus. So solving for a 2 by 2 matrix, from the illustration we have earlier, we have to multiply their diagonals and subtract it. So this is going to be equal to 5 in a bracket. So the first diagonal we have here is 4 times 6. Then remember this minus sign, we have to write it. Then minus, let's put this in a bracket so we don't make mistake. Then the second one is what? We have a minus 3 times 1. So all this in a bracket because they belong to 5. And then the next one we have here is plus 6. So what are we going to be multiplying? Their diagonals are, so remember this is the diagonal for this one. So the diagonals are 7 times 6. Then this minus sign we'll have here. So minus, then we'll have minus 3 times 2, which is the second diagonal, minus 3 times 2. So we'll close this bracket. Third one, we have plus 4. And then in a bracket, the elements there are 7 times 1. Then we'll have our minus sign here, this minus. So we'll have minus, then the second diagonal is what? We'll have 4 times 2. So we'll have to write it 4 times 2. Then we'll close the brackets. So now we have to simplify this to get, so here we'll have 5 in a bracket, then 4 times 6. 4 times 6 is 24. Then we'll have minus. So minus 3 times 1 is minus 3. So minus 3 times this minus we have here will give us plus 3. We'll close this bracket, then we'll have plus 6. We'll open. So we'll have 7 times 6, which is going to give us 42. So 42, and then we'll have minus here. So I'm going to write it minus. Then the next one in the bracket is minus 3 times 2. So minus 3 times 2 will give us minus 6. And then we'll have our minus here, which is going to be plus 6. Then we'll have plus 4 in a bracket. So 7 times 1 is 7. Then minus, we'll have 4 times 2. 4 times 2 is going to give us 8. So simplifying what we have, our normal determinant gives us, we have 5 in a bracket, 24 plus 3 is 27, plus 6 in a bracket, 42 plus 6 is 48. Now, plus 4 in a bracket, 7 minus 8 is minus 1. So therefore, D is equals to 5 times 27 gives us 135, plus 6 times 48 gives us 288. And then we'll have 4 times minus 1 gives us minus 4. So working on this together, we'll have 135 plus 288 minus 4 gives us 419. So now that I've gotten the normal determinant, the next thing we'll have to do is to look for the determinant of the coefficient of x. So now let's go back to the matrix we formed here. So from the illustration we actually had earlier, so if we're looking for the determinant of the coefficient of x, meaning that the coefficient of x from this equation, we have them to be 5, 7, and 2, which are this. So we have to replace them by the values of d. So the values of d here are 15, 19, and 46. So I'm going to remove 5, 7, 2 and replace it with 15, 19, and 42. So that is what we're going to do. Then we'll have our y and z remaining as it is. So now let's have them here. So I'm bringing it here so it will be very easy for us to work with. Remember, we are replacing this with the values of d. We are replacing with the values of d. So our matrix here becomes 15, 19, 46, and then the x and y remains as it is. So minus 6, 4, 1, then 4 minus 3, 6. So we have to look for the determinant of this value. So now that I've gotten out the 3 by 3 matrix, that means we now need to look for the determinant of the coefficient of x. We need to take note that we have to put our plus, minus, and plus for it to solve for the determinant. Now take note, the first element here is 15. So we're going to have 15, then forming a 2 by 2 matrix for 15, we have to remove the rows and column associated with it. So the rows associated with 15 are this, and the column are this. Now we are left with 4, minus 3, 1, and 6. So we have to write it in the space provided, which is 4 minus 3, 1, and 6. So the next thing is we have minus here. We're going to write our minus. Then the element we are going to be working with is minus 6. The second element is minus 6. So remember we have minus here already, and then minus 6, which is going to give us plus 6. Now the 2 by 2 matrix we are going to be forming, we're going to be removing the rows and column associated with minus 6. So the rows associated with minus 6 are this, and then the column associated is this. Now we have 19, 46, minus 3 and 6. We have them left. So we are going to write it as 19 minus 3, and then we'll have 46 and 6. So this is what we'll have next. So the third element here is 4. So we'll have our plus 4, then forming a 2 by 2 matrix for that. So the rows and column associated with this, these are the rows and these are the column. So we are left with this. So let's have it. We have 19, 46, we have 4 and 1. So now this has given us a 2 by 2 matrix. Remember, we are going to be having plus, minus, plus, minus, plus, minus. And then we'll multiply their diagonals and find the differences. So looking for the determinant of the 2 by 2 matrix we have in this, we have 15, then a square bracket. So 4 times 6, so 4 times 6, which is the first diagonal. Now the second, we have this minus here, let's not forget. So minus, the second diagonal is minus 3 times 1. So close the square bracket, then we have our plus 6, square bracket, then the first diagonal is 19 times 6, then minus the second diagonal, we'll have a minus here. So the second diagonal is minus 3 times 46. Close the square bracket, then we'll have plus 4, which is the third element there, is square brackets. Then the first diagonal is 19 times 1. Then remember we have our minus here, so minus the second diagonal is 4 times 46. 4 times 46, we close the square bracket. So now we'll have this is equal to 15 in a bracket. Then 4 times 6 is 24. 24 minus, then we'll have minus 3 times 1. Minus 3 times 1 is minus 3. And then we'll have a minus here. So this becomes plus 3. So we have plus 6 in a bracket. What we'll have here is 19 times 6. 19 times 6 gives us 114. So 114. And then we'll have our minus. Then the next thing there is minus 3 times 46. So minus 3 times 46 gives us minus 138. But because we already have a minus here, minus times minus gives us plus 138. Then we'll have plus 4, which is the third element. 19 times 1 is 19. Then minus, that's 19 times 1 is 19. Then minus 4 times 46 is minus 184, which is 184. Now we'll close it. So this is now equals to 15 in a bracket. 24 plus 3 is 27. Then plus 6 in a bracket. 114 plus 138 gives us 252. We close the bracket, plus 4 in a bracket. 19 minus 184 gives us minus 165. We'll close that bracket. So now we are left with 15 times 27 plus 6 times 252 plus 4 times minus 164. So let's have it here. So our determinant of x is equal to 15 times 27 gives us 405. 6 times 252 gives us plus 1,512. And then we'll have 4 times minus 165 gives us minus 660. So let's confirm that. So that's what we'll have here. Now, our determinant of x is equal to, when I add this and subtract, I'll be having 1,257. So now that I've gotten the determinant of the coefficient of x, let's look for the determinant of the coefficient of y. So dy is going to be, now let's go back. So at this point, we are looking for the determinant of the coefficient of y, meaning that I am going to replace the coefficient of y with the values of d. The coefficients of y here are 6, 4, and 1. I'm going to replace them with 15, 19, 46. So now let's have that. So now we're going to be having our x remains the value they are supposed to be, which are 5, 7, and 2. Now we're replacing the coefficient of y's to be 15, 19, and 46. Then the values of z remains what they are, which are 4, minus 3, and 6. Now we have to look for the determinant. So the determinant of this becomes, remember we have to have a plus, minus, plus. So the first element here is plus 5. So we'll have 5 and then we'll form a 2 by 2 matrix for 5, which is going to be the rows associated with 5, we'll remove it. The columns associated, we'll remove it. Now we are left with 19 minus 3, 46, and 6. So we'll have 19 minus 3, 46, and 6. So the second element we have to work with is minus 15. So we'll have minus 15, then we'll form a 2 by 2 matrix for it also. So the rows and columns associated with minus 15 are this. Now we'll have what's left. We have 7, 2, minus 3, and 6 left. 7, 2, minus 3, 6. Now for the third element, we'll have plus 4. Plus 4 will form a 2 by 2 matrix for plus 4. We're going to remove the rows and columns associated with the 4. Now we are left with 7, 19, 2, and 46. Now let's solve the determinant. We are now going to be having plus minus here, plus minus here, plus minus here, because we've been able to reduce this 3 by 3 matrix to a 2 by 2 matrix. dy is going to be equal to 5 in a square bracket. So the first diagonal there is 19 times 6. We close the bracket, we have this minus here. So minus, the second diagonal is minus 3 times 46. So we'll close this square bracket. We'll move to the next one. The next one will have minus 15. So we'll have minus 15. Then our square bracket, the diagonals, 7 times 6. So we'll have this minus sign here. We'll have our minus, and the second diagonal is minus 3 times 2. So we'll move to the third element, which is plus 4. So we'll have plus 4, and then our square bracket. 7 times 46 is what we'll have here. Then we'll have minus, the second diagonal is what? 19 times 2. Now, determinant of the coefficient of y becomes 5 in a bracket, 19 times 6. 19 times 6 gives us 114, minus, then we'll have minus 3 times 46. Minus times minus is plus. So 3 times 46 becomes plus 138. So we close this, we'll have minus 15 there. Now 7 times 6 is 42, minus, and then we'll have minus 3 times 2, which is plus 6. We'll close this, then we'll have plus 4, we'll open the bracket. 7 times 46, 7 times 46 gives us 322, and then we'll have minus 19 times 2 is 38. We'll close this, then working on this, we'll have 5 in a bracket. 114 plus 138 is going to give us 252. 252. So now that we'll have 252, so we'll close this, we'll have minus 15 in a bracket. 42 plus 6 is giving us 48. Now we'll have plus 4, and then 322 minus 38 will give us 284. Now, our determinant of the coefficient of y is 5 times 252 is 1,260, minus 15 times 48 is 720, plus 4 times 284 is 1,136. So when we do the addition and subtraction, that's 1,260 minus 720 plus 1,136 will give us the value 1,676. Now that we've gotten the determinant of the coefficient of y, let's get the determinant of the coefficient of z. So moving to the original matrix we formed earlier, so this is z, and these are the coefficients of z. So the coefficients of z are 4, minus 3, and 6. We are going to replace it to the value of d. We're going to replace it to the value of d. So x and y remains the same. We are only changing z to be d. So now let's have that. So determinant of z becomes, we are going to form the matrix here. So like I said, we are having our x to be the same thing. Our y remains the same thing. But z are going to be changing to d, which is 15, 19, and 46. Now let's form our determinant. So remember, the first thing to do for a 3 by 3 matrix is to do your plus, minus, plus. So the first thing is 5, then form a 2 by 2 matrix. We are going to remove the rows and columns associated with it. So this is the first element we are working with, 5. The rows and columns associated with it is this, and then we are left with 4, 19, 1, and 46. 4, 19, 1, and 46. So the next element we have here is minus 6. So we are going to write our minus. But take a look at the minus we have at the top. We have this minus at the top, and then we now have minus 6 as the element we are working with. So it's going to be plus 6. Then the rows and columns associated with this is, these are the rows and this is the column. So we now have 7, 2, 19, and 46 left. 7, 2, 19, and 46. 7, 2, 19, and 46. So the last element there is plus 15. So we write plus 15 and form a 2 by 2 matrix. A 2 by 2 matrix for 15, we're going to remove the rows and column associated with 15. Now we are left with 7, 4, 2, 1. Now let's solve this 2 by 2 matrix. Remember, plus, minus, and plus, minus. So our determinant of the coefficient of z becomes 5 in a square bracket, the diagonals, 4 times 46, put this in a bracket, and then we'll have our minus sign here. So this is minus, the second diagonal is 19 times 1. We'll close this bracket, then we'll move to the next element, which is plus 6. So the first diagonal is 7 times 46. Then this is our minus sign here, minus the second diagonal is 19 times 2. Then we'll close the bracket, plus 15. Then our square bracket, 7 times 1 is the first thing we'll have there. Then minus, we'll have 4 times 2. Now expressing this further, we'll be having 5 in a bracket. 4 times 46 is going to give us 184. 184. Then we'll have minus 19 times 1 is 19. We'll close the bracket. We'll go to plus 6. 7 times 46 is going to give us 322. Then we'll have minus 19 times 2 is going to give us 38. Then we'll have plus 15 in a bracket. 7 times 1. 7 times 1 is going to give us 7. Then minus 4 times 2 is going to give us 8. Now we have determinant of the coefficient of z to be 5 in a bracket. 184 minus 19 is 165. Then plus 6 in a bracket. 322 minus 38 is going to give us 284. Then plus 5, that's plus 15 in a bracket. 7 minus 8 is minus 1. So this is equal to 5 times 165 is 825, plus 6 times 284 is 1704. Then we'll have 15 times minus 1 is minus 15. So working with this value, our determinant of the coefficient of z is 2514. That's if you add and subtract them. We add the values and subtract what is given. Our determinant of z is 2515. So now we can observe that we've gotten the determinant of z. We've also gotten the determinant of the coefficient of y. And we've gotten the determinant of the coefficient of x. And we also got the normal determinant. So what is the formula to get x and y? So the formula to get x is what? Determinant of the coefficient of x over d. The formula to get y is the determinant of the coefficient of y over d. And the formula to get z is the determinant of the coefficient of z over d. Now let's get the value of x. So therefore, x is equal to the determinant of the coefficient of x all over the normal determinant. Now let's go back to see what the value is. The determinant of the coefficient of x is 1257 and the normal determinant is 419. So now let's go back to put it in the value. So we'll have 1257 divided by 419. Our value here, when I divided this, we got 3. So now looking for the value of y, it is going to be the determinant of the coefficient of y over d. So we know the value of d as 419. Let's look for the determinant of the coefficient of y. So the determinant of the coefficient of y is 1676. So let's put that here, 1676. So when I divided this, value is 4. Now to get the answer for z, it is the determinant of the coefficient of z over d, which is equal to, our d is 419. So let's confirm the value of the determinant of the coefficient of z, which is 2,514. 2,514. So after doing the division, the answer is 6. So therefore, you agree with me that x is equal to 3, y is equal to 4, and z is equal to 6. So this is the answer of this system of linear equation involving 3 variables. So these are the solutions for question A, and for question B, which is this, we're going to be solving and dropping the solution to this question in our next video. If you've joined me to this point and you have any question so far, you should drop it at the comment section. I will respond and give you feedback concerning your question. So now let me leave you with this simple question to work it and test your knowledge. So I want you to do this during your leisure time. So we have x minus 4y minus z equal to 11, and then we'll have 2x minus 5y plus 2z equal to 39, and minus 3x plus 2y plus z equal to 1. You should do this during your leisure time. So whatever answer you get, drop it at the comment section. I will check and give you feedback. Maybe you got it right or you missed a step, but definitely I will respond and give you feedback concerning the work you might have done concerning this question. Thank you very much for joining me to this point. Thank you so much for your time. Thank you for the support you're giving to my channel. And if you enjoyed this video, do not forget to share it with your friends who might actually need help with CRAMER'S rule. And please like, subscribe, and drop a comment. Yeah, just tell us something nice at the comment section. So thank you very much and see you in my next class. Bye.